Welcome to another video from Lockdown Electronics with me, Bill. This time we're going to take a look at this quite heavy box. It's the second box sent in by Adam. If you've not seen the previous video about some of the goodies that Adam sent me, it's worth doing that. I'll put a link up there for that. So let's get right to it, get this box on the bench and see what goodies are in store. Okay, so here's Adam's second parcel, and apart from undoing the top and having a read of the note, I've actually not delved into it properly, but in the note Adam essentially tells me that he's sending me a few more bits, a signal generator, an attenuator, both items that he's made, and a DC to DC boost, a 3.2 inch Nextion touchscreen display. That's actually something I am familiar with because I fitted one to my UBitX HF transceiver. In fact, there's a video to that. I'll put a link up there to that video. And it says there's a homemade component tester. Use mains power, needs adapting for protective earth. And he says no schematic, it was built a long time ago. So that sounds like that might be a form of curve tracer, so it'd be interesting to have a look. So I don't think we're going to look in detail at everything that's in here today, but maybe we can have a look at a couple of things. So I'm going to guess that the fact that says Nextion on it, that is the Nextion display. Certainly looks that way. Yeah, oh gosh, yeah, that's a nice big 3.5 inch display. So that's Nextion display is quite useful for an Arduino because it takes some of the processing of the display away from the Arduino, and you have to program the display itself using a micro SD card. Right, not sure what this is, but we'll have a look. Looks like there's this looks like the mains lead, so there is a transformer of some description there. With a mains input and a fuse, and then there's Y and X, so I'm guessing that's what goes to the oscilloscope, and these will be the testing probes, I guess. So that's something I'm going to have to set up and look at with an isolation transformer, but I will do that in a future video because it'll be interesting to see how this performs as a curve tracer. So that's very good, thank you, Adam. Going to carefully roll that back up in the bubble wrap. Okay, so digging in a little bit further, we've got what looks like yet another note. I think it's actually a circuit diagram, to be honest. Yeah, so that looks like it's a circuit diagram for the signal generator, using the AD9833 generator board driven by an Arduino, and then this LM318 op amp is being used, I guess, to control the output, and also as a buffer to that chip. So we'll have a look at that in a moment, and I'm guessing that's what's going to come out next. Yes, here we go. And as usual, as you perhaps saw from last time with Adam's project, very nice box. Says 5 volt DC, 100 milliamps, center positive. So there's a rotary encoder there, an output, a couple of controls, and it's labelled on the top as to what that is. So that's the signal generator. So we'll have a look at that in a moment. And then we've got some foam in here, and I'm suspecting this is going to be the attenuator. So let's just have a look at that. That's in a very nice metal box, actually, which is probably a good thing for a RF device. So there we go. Yeah, okay, so in and out, and 5 volt center on the supply again, with a rotary encoder and an OLED display. So we'll also get that connected up and see what it is. So another very nice set of goodies to play with. So thank you, Adam. Let's now get set up and try a couple of these out. Okay, so I've got the Adam signal generator connected to a 5 volt supply now, and Probably can't see it very well in the camera, but the little OLED display is telling me that it's 216 kilohertz sine wave, and the scope indeed agrees, 216 kilohertz sine wave. So top one is amplitude there, yeah, definitely works, and that offset does exactly what it says. It offsets the wave either side of center. So I'll get it back in the screen there, and turning the rotary encoder slowly increases the frequency. I'm going to just whiz up to about 300 kilohertz. There we go, 300 kilohertz, and indeed scope saying 299.994. Don't know which one's right, but certainly close enough to say the least. So that's a really nice waveform being output there. It goes up to 500 total, so I'll just take it up somewhere near the top here. That's there we go, that says 500. Yep, 499.991 kilohertz is what that's saying, and that should still be attenuating. Yep, so we can increase the signal quite significantly there. It's got quite a strong output, and it's, in terms of its amplitude, as I come down, it's remaining pretty constant really. That's very good. So I'm now back down to about, well, I got back down to 200 kilohertz, and pressing the encoder changes the wave shape. So that's triangle, which, yeah, I would say that was a pretty good triangle wave. And then we should get square. Now that's a lot stronger signal, but yeah, that's a pretty reasonable approximation of a square wave. Obviously there's a module in here generating this this waveform. The Arduino is simply telling it what to do, so that's pretty good. Quite a fast rise time. So yeah, that's your 3 sets of outputs. So that's a pretty nice bit of kit really. If you'd got that in your lab as a signal generator, I think you'd be more than happy with that. So nice one, Adam, you built a good little project there. We'll have a look inside now, see what's what. Okay, top lid of the signal generator removed, and as I expected, as we've seen with some of Adam's previous work, very nicely done indeed for a homebrew signal generator. This is really nice. So there's some kind of voltage regulation in there, can't quite see, it's covered in heat shrink. That comes in from the DC socket. We've got an Arduino Nano here, which is doing the heavy lifting in terms of driving the OLED display there, and also talking to the rotary encoder here. So that's what those two cables are. And then this is the signal generating module just here, and it's powered off, so should hopefully be able to gently remove that. So you can see there we've got a crystal, and if I just turn that so you can see it, so it's AD 9833 or a 9837 or AD 9837. So there'll be the reference crystal. Here's the chip doing the work, and obviously it's on that little fragment of circuit board there. So that's quite nice, neat little package. Let's carefully pop that back in like so, and then Adam's very thoughtfully provided some offset and some attenuation using this op amp here, and the whole lot is very nicely mounted on a piece of Veraboard. So yeah, nice job, I like it, very good. I think you could be very proud of that, Adam. I'd be very pleased if I'd built something like that. Okay, I'm struggling to get everything in focus, but hopefully you can see both the spectrum analyzer and also the display of the attenuator. So I've got it powered on. Currently it says 0 dB. So what I've done here is that it talks about maximum input of 24 dBm. So I've got my tracking generator set at minus 10 dBm, so I'm well within, so I'm not going to be overdriving it and distorting anything. And I've currently got the two SMA leads connected with a through connector. I've normalized the display so we are running exactly on 0 there. So now what I'm going to do is connect up the various bits of the attenuator. So first of all, I'm going to attach the tracking generator to the input, and the input of the spectrum analyzer to the output of the attenuator. Okay, there we go. Right, hopefully you can still see everything. So what we've got now, the attenuator is set to 0, and it's maybe losing a couple of dB, but not a great deal. And so we've got from 0 to 2.1 gigahertz on here. So that's the full width of the spectrum analyzer sweep that I can get here. So right up to 2.1 gig, and it starts to become a little less level, above about 1.8 gig, but it's pretty linear up to that point. That's 1.05 gig there, so it's probably about 1.5 gig somewhere there before it starts to have a few little undulations, but it's not that bad. So let's dial in some attenuation. So I'm going to attempt to get 10 dB or minus 10 dB, and yeah, if you remember, we lost about, I don't know, half a bit. In fact, I'll tell you what we'll do, because what I really ought to be doing is I really ought to be normalizing this when it's through the attenuator. Okay, so now I've normalized through the attenuator, so we've got a straight line there. So let's now dial in some attenuation and see how we get on with that. Let's see if we can get up to 10 dB. Okay, so there's 10 dB. Yeah, pretty much bang on, exactly 10 dB, and right up well beyond 1.5 gig we've got a nice straight line. Let's see if we can get 20. Okay, there's 20 dB. I was fighting the rotary encoder there. I've noticed there's a binary display underneath there. It's probably very hard to see in the camera. That must mean that the encoder chip is set for parallel communication. It can do either parallel or serial, and I guess that's the data that it's being sent. So 20 dB, and indeed, yeah, we've got 20 dB, and it's pretty linear up to about 1.5. It's not so bad beyond that really, but it's doing very well for a little homebrew module. I'm going to try and get 30 now. Okay, there's 30 dB, and starting to get a little bit of noise on the frequency on the trace at 30 dB, at minus 30 dB, but the spectrum analyzer certainly agrees. Your signal has been attenuated by 30 dB. So yeah, again, that's a very nice bit of kit, and it's doing its jobs very nicely. And the fact that it's flat like that is sort of testimony to I think to Adam's careful routing of the cables from an RF point of view, because obviously we're into microwaves up here, and it's still coping pretty well, so nice one. Okay, so let's have a look inside the attenuator now. Obviously with the bandwidth, as we've just been looking at there, a metal case is entirely appropriate. So I've taken out the 4 screws at the top, so that should allow the top part of the board to lift off, which indeed it does. And there you can see the insides again. Very nice standard of construction there. So we've got an Arduino here doing the processing, rotary encoder and the display, and obviously those 2 connectors there are connected to the Arduino. And then across here we've got the attenuator module mounted upside down. I can't pull that out because it has an earth lead soldered on there, so to remove that board would require me to unsolder, which I don't want to do right now. But as you can see, we've got coaxial connectors and SMA connectors connected directly to the board inside, so that should, from an RF point of view, be very good. And I see there's a bit of shielding on the back of the OLED display as well. I'm not sure if Adam's done that as an extra, whether that was part of it, but certainly it keeps any noise that might be producing away from the RF path. So once again, very nicely done. I'd be pretty proud of something I've had produced like that. Okay, so there we've got it. There's two of the goodies that came out of Adam's second parcel. That's the variable attenuator and the signal generator here, and both Arduino projects, both very nicely done indeed. Now I'm aware there's also the component tester, which I'm going to need to have a play with. That if I start doing that now, that's going to make this video a little bit longer than I'd like, and I also need to carefully explore that, as it's going to involve some higher voltages. So I will produce a video on that just as soon as I've got my head around how it all works. But there you go, two nice little items from the box of surprises. Okay, well there you go, some interesting things inside that box, and a couple more things I've yet to have a good look at, but I certainly will. I want to try and get that component tester going, see if we can get that working, as which I'm guessing it's a curve tracer. I think it probably is, but we'll have to see. So if I can get it going, that's going to be subject of a future video anyway. So thank you, Adam. I have to say that probably a number of times. I'm very impressed with your constructional skills. Apart from uploading some already written sketches to a couple of Arduinos, I wouldn't know where to start with programming them, but I think he's made some really nice use of the Arduino in controlling some of these boards, signal generator, or the attenuator board. Nice job. But also he clearly knows his stuff, because we've got the electronics there for the gain and for the offset in the signal generator as well. So nice little job. I'm actually quite humbled that somebody thinks the channel worthy of sending some things in, so I really do appreciate that, and I hope you've enjoyed exploring the contents with me. Thanks very much for watching. Please click the thumbs up, and if you haven't already subscribed, doing both of those things really helps the channel. Costs you nothing, but it'll certainly help me, and we look forward to seeing you on the next video.